I love her.
Yeah.
You did better than Fox News. They put up like an Aretha Franklin picture saying that she died, and then in sort of like just in the background, it had another completely different.
Oh man, You can go ahead and finish, John. What did Fox News do? People love it when we talk shit about Fox News. Well, what do they do?
Well, they had an Aretha Franklin image that was like, oh, she died, and then it also had a different singer like in the background of the picture. But it was like, oh, look, here's black woman singing. There's black woman singing.
Right.
There's same black woman.
Same thing. Same thing. Now, if it would have been a country singer, oh man, they would have stopped Fox News for like a 60 seconds, moment of silence.
Yeah.
Well, welcome to Ideology, everybody. We have, Hey, y'all.
How's it going, everyone?
This, by the way, is Dr. Croon, and we're going to introduce him properly here in just a second. I have his amazing resume pulled up here. But as always, since we have John, we heard from John just a second ago, he has to do his customary intro. So let's let him say hello to everybody. Come on, John.
What's up, heathens? How y'all doing?
Excellent. Okay, I feel complete now. So
I'm glad he gets to say hi before I do on my show. It's great.
The floor is now yours. She's so angry. Casey's
hi, y'all. I am.
doing?
I'm very angry.
How are you doing, Casey?
Do you know what would help me?
What's that?
Well, there are a few things, but jokes. Did you know, Kyle, today is National Telejoke Day?
It is. Stop
it is.
Stop
it is. So GE and I have prepared a special National Telejoke Day treat just for you, and it's perfectly themed for tonight's episode.
Dr. Croon, are you ready?
Absolutely.
All right.
Let's do this.
Hey, Kyle.
Hey.
So exactly when is someone going to explore the mysteries of Uranus?
Last Tuesday.
Hey, did you know that there's only going to be 6 planets after I destroy Uranus?
You promise?
Also, you know, with our new reflecting telescopes, you can definitely just use 2 hands in a mirror to see Uranus.
What's the best about this is that voice. Does that voice have a name job? Because I noticed that you use him in when you're either reading comments or whatever. You should theme that.
It's just hillbilly knees.
Yeah.
It sounds like his name would be Brett. He would do CrossFit and wear Axe body spray.
Only if Brett had 3 teeth.
You can't read your own handwriting?
No.
Damn engineers.
He probably can't read it because it's pitch black dark in there.
Yeah, actually, that's a little bit it. Hey, did you know that the other night astronomers looked out into the universe and were excited to see Uranus?
I totally can believe that. I sense a theme going on here.
Also, did you know that there are secret plans at NASA to strap 2 rockets on a white dwarf and ram it into Uranus?
Sounds like my Saturday night.
Oh, and by the way, don't worry about it. The world's going to completely end when Uranus blows. Okay, so you don't have to worry about that none. Bravo. I think we are. Oh, is that it? Or you got?
I think is that it?
Well, I got one more.
I
was just now able to read my scribble. Now, listen, there on Kyle's for Kyle here, no women have ever explored his anus, but
wait a minute.
I can guarantee you that men have been all over his Uranus.
You did his anus.
Wait a minute. That is, let's just say that is factually incorrect, and we'll move on from that.
It's factually incorrect.
That's factually incorrect.
There
okay,
has
so
a woman who has destroyed.
Let's transition from
anus.
that into.
Hold on. Thank you, heathens, for allowing me to tell my shit jokes.
Well played, sir.
Your asshole jokes.
Thank you, Godless Engineer, as always, for stopping by. This will be his 65th appearance on this show, so he is somewhat of a legend. He holds the record. Today makes 65 appearances on this show. So
I'm like the third leg of
Uranus.
Uranus. There you go.
Yeah, I'm not sure if that's a prize or not. I don't know if that's a positive or not in your category there, John. But anyway, we're lucky to have you.
Thanks for having me.
Now let's transition from that into this. Number one, I said this a little bit ago before we started the call. I'm always not only thrilled, but sometimes shocked and maybe even a little skeptical when we get people who are like the PhDs that we have on here. They're just brilliant, and skeptical in the sense that maybe they mistakenly sent their intention of wanting to come on the show to me and meant to send it to somebody else. And none is more true than when I read the gentleman that is with us now. I'm just going to read it and you will understand why.
Yes.
Dr. Croon is a astrophysicist. Ugh.
Kyle can't even say the words.
No.
He's still thinking about Uranus.
Oh, God.
Try that again.
Sorry.
Yeah. Oh, man. Dr. Croon is an astrophysicist and programmer with a doctorate of philosophy and physics with a focus on analytical high-energy astrophysics. He is currently an NRC postdoctoral researcher at the Naval Research Lab, responsible for leading the analysis and mathematical and computational modeling of gamma-ray flares from the Crowd Nebula, and publishing several referred journal articles. Previously, he was responsible for addressing collaboration issues of laboratory equipment, including the application of techniques to quantify and characterize the transmission properties of coupling media between organic... Oh, man.
Scintillators.
Thank you. Scintillators and fiber optic systems. See, it tells you something when I can't even read the man's resume. But nonetheless, it is a pleasure to have you. Welcome, Dr. Croon. And once again, thank you for coming on and doing this talk with us.
Thank you for having me.
So tell us how did you come across us? I always like to discover that.
So... while my computer code would be compiling, because you see, I try to focus, on my work during the day, I might have found maybe several minutes, upwards of an hour of time to kill. I would make myself a sandwich and, go onto YouTube and look up, science videos. I'd watch Cosmos, sometimes little snippets of Cosmos on Netflix. And then I saw a Facebook post about some flat Earth movement, and I was like, "There's no way! Like, what do you mean? Like, we have 4K, 360-degree, like live video feeds from the ISS. No time.
CGI.
Yeah, there's no time to broadcast that live. And then anyway, so I was just looking around on YouTube about flat Earth stuff, and I watched a handful of flat Earth videos. And came across your guys's and saw that they weren't just like every other video I had watched up to that point, which were like 5 to 10 minute like word vomits of just crud, and then some rebuttals that were cool to watch. Instead, I wanted to see more about like why people were thinking this, why this was a thing, and to do that you need to have a conversation, you need to have a discussion, even if it is somewhat fruitless. And
somewhat.
You guys are the only ones I found that have this like open forum discussion so that we could address problems of the day, and problems of the past and problems of the future and discuss them. And so I really enjoyed watching all the videos that I've seen so far, and I would make chicken curry, and it'd take about 2 hours, and I would bust out a whole 2-hour episode of your guys's while cooking dinner. And so it was a lot of fun to cook and be entertained at the same time.
I feel like I should apologize to you because I feel like we're taking away. You're using that time where you could be watching stuff like Carl Sagan on Cosmos or real science videos, and you're watching people that don't believe in dinosaurs, and I feel like that's something that
he's seen it before.
I should apologize to you for.
It's not new. Don't worry about it.
But nonetheless, thank you so much for that compliment. That means a lot, and I think that's something that has been lost the ability to just come on here and talk. And Casey, actually, when we had Joe on the first time, the guy that doesn't believe in viruses,
Or dinosaur
she was
bombs.
like, yeah, well, I don't think that I think that he was bullshitting on that, but
Maybe.
I think he honestly believes on the virus thing. But Casey was like, oh, I have the perfect person. Let's get Dr. Peachy Keen on here. And she could have been the person to answer his questions. So our focus kind of is to, yeah, you may believe something crazy. And I'm all about free speech. And I think that you should have the right to come on and be crazy. But you should also be willing to learn something from people who know it and who do it on a daily basis. And that's the problem that I see. Yes, we'll put these people on a platform and we'll put them with people that can answer their questions and who are experts in the field, but it stops there. They're not willing to let go because it's something that's kind of made them different. You know, they have a purpose because their purpose is to go out and say that viruses don't exist. And it's disheartening. It's so disheartening. But nonetheless, so today we're going to be talking about exoplanets. And Casey, do you know anything about exoplanets?
Not a fucking thing.
Awesome.
I know I was looking through the slide deck and I saw a word that vaguely resembled Kardashian. So like,
oh, the Cardassia.
Yeah.
I saw that too. I thought the same thing. I was like, oh man, this planet must have a big bump coming out the side of it or something because that's.
I don't watch the Kardashians. I was just like, hey, that's funny. So no, I know nothing about exoplanets.
Well,
so
excellent.
I'm looking forward
good.
to it. Usually I do like a little bit of like research coming into it, but work has been crazy, school has been crazy, so I just haven't had time.
Well, I think it's perfect that you don't because it'll give you the opportunity to ask like I don't know a whole lot, but
Yeah.
Dr. Croon has prepared an amazing presentation for you guys today, and it's very detailed. And I told him that he probably compiled about 4 shows worth, so you'll be seeing Dr. Croon a lot on here. And at this time, I'm gonna turn the reins over to you, sir, and take us on a journey through the cosmos. All
right. So before I begin, I'd like to just define, just so that we're all on the same page, what is an exoplanet. It is a planet outside and independent of our solar system, not like Planet X or Planet 9, like conspiracies about like some doomsday planet in our solar system. We're talking about entirely separate solar systems. You look up at the night sky and see these stars, and most, if not all of them, we will learn tonight and in the future have at least 1 or 2 stars. Some have even 5, 6, 7 planets around them. And so, that's an exoplanet. Exo meaning like out or above or beyond. And planet, of course, means planet, which of course comes from a Greek word, planetes, that means wanderer, because down on the Earth surface at night, the planets, they just look like stars. Some of them pretty bright, like Venus and Jupiter. In fact, we got the Mars opposition going on right now, and so that one's about as bright, if not a little brighter than Jupiter right now. And so they looked like stars, but they moved against the background of the relatively stable constellations. And of course all the mythology and that followed in order for them to try to make sense of the world around them, and in particular the night sky, because it is arguably a very beautiful sky, certainly more so back then when there wasn't a single city light pollution light bulb, probably just torches and campfires or whatnot. And so humans have always had a deep connection with the night sky. You know, they at least in the northern hemisphere in particular, they told you when to harvest your crops, when to plant, when to start planting, when to harvest them. You know, and you have things like the harvest moon and stuff. It's that full moon, the last full moon before the first frost of the colder months of the fall and winter. And so that is one of the things that precipitated out of just simply looking up at the night sky, is this connection that the stars have with the seasons on Earth. Of course, it's just because Earth is going around in its orbit, and then you see different constellations at different times of the year. But that was a very good sort of acid test, a good indicator for ancient civilizations all the way up through even now, really, of when you harvest your crops and all kinds of stuff. In fact, the term disaster comes from a term that means bad star. So you have like these comets that would come, and it was like out of the ordinary. If you see something out of the ordinary, and you've been used to for thousands of generations, a set of constellations, you're like, whoa, this could be bad. And then, well, there's always bad stuff happening in the world, unfortunately. Wars, tribal wars, sicknesses, maybe crops destroyed by a really late frost in the spring or early frost in the fall. And so they ascribed an omen, a sense of omen to comets. And so that's where we get the term disaster, bad star. So that's kind of interesting. So back to the planets. So planets in our own solar system started out as looking like stars because they're so much smaller and they're just reflecting light from the sun, but they're so much closer to us than the actual stars are. And so they could look similar, but they definitely are distinguishable. And you could, of course, see them through a small telescope and distinguish them as actual planets, like Galileo did in the 1600s with his telescope, a refracting telescope, where he was able to see the four what we call Galilean moons orbiting Jupiter, because they're the four innermost moons out of like 69. I think they just found 12 more even. And so at the time, the prevailing scientific...
12 more?
Yeah, there was an article just this summer about 12 more that were discovered around Jupiter. They're probably mostly like large asteroids. If you see some of the moons around Saturn and Jupiter, they're like very odd, like potato-shaped and globular and small, somewhere between a few miles up to a couple dozen miles or whatnot.
How would they just discover that? Like, if we've sent probes to Pluto and back, how would they just now be discovering?
Well, because
like,
they're so small and not very reflective, and we have the Juno probe that has been orbiting Jupiter and getting the highest resolution images of it. I don't know if Juno actually was the thing that discovered those moons, but we're taking closer looks at the planets, and even the Cassini probe just did its fateful dive into the Saturn's surface, cloud tops, if you will. And so, yeah, I mean, space is huge, and even moons, which are bigger than humans, they're still pretty small and not very reflective. They're like coal and dirt sort of colored. But yeah, so Galileo was like, hey, like everything's supposed to revolve around Earth, right? Like, so here's Jupiter, and it's got these like 4 points of light, and he actually followed them over many, many nights and saw that the one closest to Jupiter went around it. Which the fact that they went around Jupiter at all was like, groundbreaking if you think about it, a paradigm shift away from geocentrism. But he recorded their the period that it took for each of the moons to go around, and so I'm mentioning this because later in the show we'll come back to Jupiter's moons, some of them, and see that maybe you don't have to exclusively look at planets for habitability and maybe some life forms and whatnot, but perhaps even some moons around some of the planets in that solar system. So that's like my little intro, just sort of get the exoplanet juices flowing, if you will. And today, yeah. So tonight I would like to restrict my attention to two missions in particular, the Kepler mission and the TESS. Kepler launched in 2009, and it's pretty much done. It even had a major catastrophe in 2013. I'll get to that later. TESS, the transiting exoplanetary satellite. Explore, something like that. I can't remember what TESS stands for. It's the latest and greatest in exoplanetary hunters that launched just this past March. So, and it has a 2-year planned mission. Then I would also be discussing with you guys the two main sort of techniques, like how do we actually find exoplanets, like what methods, like how do we do that? And then I'll get into the meat of it. If you will, I will go through a very small selection of actual exoplanets and discuss some of their properties. And that's I've literally I chose like a handful between 5 and 10. There are, as you'll soon see, actually thousands of exoplanets that have been confirmed, and even more that are candidates awaiting confirmation. And then we'll look into the future, and also some sort of tangential derivative concepts associated with this whole talk, which is essentially an open conversation.
Let's start out with what constitutes a planet or an exoplanet. Like, what's the criteria that it has to meet before it's categorized as that?
So do you mean like the definition of a planet, or how do we know that we've discovered an exoplanet?
Yeah, because there's the whole the Pluto gate, and there are people that consider Pluto a planet. But can you explain why it's not, and what makes what the differences between the two?
Yeah, so it has to meet all 3 of the 3 criteria. Itself into a spheroidal shape. It has to orbit the sun. Pluto meets both of those criteria, and as you could probably guess, it fails the third one, which is it has to have enough sort of gravitational oomph, dominance to clear out its orbit. It does not do that. It actually even crosses inside the orbital radius of Neptune even. And it's even, if not that it matters too much, but it's tilted like a lot, like 20 some degrees out of the actual plane of our solar system. And so it's just, it doesn't meet that last criteria. But here's the thing. This is one of the reasons why I get annoyed when people get all upset about Pluto not being a planet. It's been classified as a dwarf planet. So it's still got the word planet in there. It's just as we start discovering new planets and thinking about our own solar system, our definitions will be refined, and that's the part of the process, You
just kicked it out of the club because it's a little different than the rest of them. That's mean. Science is mean.
Well, listen, I don't understand. I don't understand the outright. To me, it's one of those things where it's like, what do you care what they call it? You know what I mean? Like, why do people get personally attached to?
Yeah.
And this is gonna garner me several comments on this video, because there will be somebody that will bitch me out for not taking Pluto's side. But I don't get it. I mean, I really don't. I don't understand the attachment to a planet's name like that.
Yeah. It's still there. It still exists. It hasn't even gone around the sun once since it was discovered. And I should know, it was decades and decades ago that it was discovered. And we only just finally got the first ever pictures of it with that New Horizons. And it looks quite amazing. You think it's just like a boring, dead, like ice ball, but it's got like a lot of features, a lot of cool chemistry going on there. Surface chemistry.
Isn't there we might be getting ahead, but it's been killing me. It's been killing me. I have to ask. Isn't there a planet where it rains diamonds?
Yeah, I heard. I didn't include that one on our list because.
Did you hear that, GE? Did you hear that? There's a planet that rains diamonds.
Okay, so it would be like a planet that has it's very dense, and it doesn't have a lot of volatiles, things that like readily evaporate, like water and methane, ice, and liquid nitrogen and stuff like that. It's I don't remember the planet's like official name, like what catalog and all the naming system, but it is said to likely have an extraordinary amount of carbon, and carbon likes to be in one of a few forms. It likes either to be in a carbon allotrope that we call diamond, or it likes graphite. And so it's more likely to be an allotrope form because the graphite forms under certain conditions only. And so they think that it could be raining, not like diamonds in the like a diamond in the rough. It won't look like something from Hellsberg or K.
Damn. Well,
Except for the planet might start with the letter K, which is funny.
Godless engineer, I don't know if you caught that, but Casey was just hinting that she wants carbon allotrope at some point. So.
I know.
Okay. All right. So
Polished.
I didn't mean to distract you, but that's like with this subject, I think that there are so many like different ways you can like. Where do you start with the galaxy? It's full. I mean, it's vast. It's never ending. There's untold amount, and we were talking about this in our call actually that you and I had a couple weeks ago. We got lost kind of in the rabbit hole of where would it end, and imagine all of the different things in the way from the starting point here and out there at the end. But to have planets there's some planets that shoot geysers out from their crust, one rains diamonds. I mean, that's cool as hell. That's amazing.
Yeah, the startling amount of variety, I guess, shouldn't have been surprising, but it is, because it's like every single planet that we find, and however little we may know about it, they're all unique, and they always got these really interesting, very different properties. So, and so there's kind of like there's three different categories of exoplanets. This is a good pivot point. So there's hot Jupiters. They are around the mass of Jupiter or larger, and they're oftentimes found really close to their parent star, and it's hot there. And when you heat a gas, it tends to expand and bloat, and so making it appear even larger, but its mass would be whatever it is. So those are the ones that we started finding at first. In fact, what's known as the first exoplanet is called 51 Pegasi B. B as in Bravo for finding it. It was discovered in...
Name, though.
Huh?
What an awful name. Couldn't they be more creative than that?
The first
they all have
exoplanet?
terrible names.
Oh yeah, I was gonna say that astronomers have a way with words. I mean, some of these planets' names are HD 208591b, and it's like, talk dirty to me. It's all poetic.
GE just said that's the Jerry planet. Just let GE name all the planets. It'll be
awesome.
much more entertaining for y'all at work.
Yeah.
Jerry planet.
Yeah.
So yeah, 51 Peg B. Hold on. This is like as good as water, only better. 51 Peg B. It's a hot Jupiter that's so close to its star, which is in the constellation Pegasus. Oftentimes you'll have the constellation name abbreviated, like Peg in this case, and then B for the planet, not the star. 51 Peg is the star. 51 Peg B is the planet around that star. And it has an orbital period of about 4.2 days. It goes all the way around its orbit in 4.2 days. So it is whipping around it. I wish I wrote down the speed. It's a fast speed. And it's really close to that star too, so it's really hot. And it's a pretty massive planet too. And so for the first several years of this budding new field, we were only discovering hot Jupiters, by and large. And people were like, "Oh, see, I mean, these are not planets that, by any stretch of the imagination, would be habitable. They don't even have a solid surface to stand on, and they're like scorching hot." But that was due to what's called a selection bias, as the nascent techniques and equipment that was used to observe these cameras and software and such they were more likely to see Doppler shifts, which we'll get into in a moment, that had the strongest signal. So 51 Peg B was discovered by Doppler shifts. So planets don't actually orbit the star's geometric center, like the star's center of mass. If you would think that, like in a classroom setting, like in your head, like that model of a solar system, the star is like so massive, and that's generally true, especially compared to the planets. Our sun holds 99.9% of the mass of our solar system. Even ginormous Jupiter, where you could fit 11 Earths side by side to stretch just the physical diameter of Jupiter, and Saturn, and Neptune and Uranus, and then of course all the comets and asteroids. The sun has 99.9% of the mass. So, where was I going? All right, yeah. So they don't orbit the geometric center of that star. They orbit what's called the barycenter, which is the center of mass. Like think of like a level, and they orbit like where the mass is balanced. Like you have these tiny planets that are really far away, and then like this huge sun that's like really close to the fulcrum, and so everything orbits that. And so even our star, the sun, has a little bit of wobble due to being tugged on by all these planets.
So it's not like it was like we see it in school, where it's the center around.
Right. Yeah. As you study the solar system in higher grades, if you were so inclined to do, then the details get more sophisticated. But most people, a basic understanding such as what you described is sufficient. And so that's cool. But right. So there's all these other effects going on with the gravity and mass and all that good stuff. So looking at 51 Peg B. This large Jupiter-like planet is orbiting really close, so it's tugging even more strongly on that star, and so the star is going to wobble a lot. In fact, and it also has such a fast wobble because the planet is so close to it. Kepler's laws mean that since it's so close, since it has such a short day. Since it goes around the star so quickly, it has to be very close to the star. So it has an extreme effect on that star, and the star's light is blue shifted whenever it's coming towards us and along our line of sight, and then its light is red shifted when it's going away. And using spectrographs, like think Pink Floyd, just take the whitish light, the overall light from that star, pass it through a prism, magnify it. This is the way they used to do it. Now we have like a hypersensitive, like CCDs, like pixels in a spectrograph, and so you can actually see the wobble of the star by looking at the red shift and blue shift, and you could populate a graph as a function of time, and in this case you wouldn't have to wait very long because it's going around so fast. So it was pretty easy it was pretty quick for them to get a full sinusoidal period and then some to make sure that they had some good data fits and their error bars were tight. They do the statistical analysis, and from looking at the amplitude and the period of the of your data wobble, red shift to blue shift and back, you could actually calculate the planet's size and its mass. And the way you do that is it's a confluence of a variety of different physics. First, you have to realize that in stellar, am I rambling too much, or do you guys have any questions yet?
No, not so far.
All right,
I'm just laughing because you said physics, and I'm like, we need Steve.
Okay. Sorry, someone's calling me. Why? I told people to hang on. Oh, okay. Sorry.
There's somebody in the chat named. There's somebody in the chat named David Kroon.
Oh, that's my my cousin. Huh. Okay.
Oh, I was gonna say, wow, you've already got you an imposter. That's impressive. How do they
my other cousin's name is John Kroon, just like me.
Yeah.
When you talk about how they're able to get the diameter and the size of the planets for planets like we were just talking about a second ago, the one that has the one that rains diamonds, how can they tell something like that? Like, if it's in another galaxy or whatever, but they still say that it's an exoplanet. How are they able to say what that composition of that planet is?
Yeah.
Like,
So when we get to the atmospheric part, well, first of all, okay, the simplest answer to your question without getting ahead of myself is that you can measure the mass of the planet, and you can measure its physical size. And if you assume it's essentially a perfect sphere, you can calculate its average density. And let's say you get an average density of 1 gram per cubic centimeter. Well, that's the density of water. So it's not going to be all water. And if you look at the absolute size of it, and it's like huge, you're looking at probably a gas giant or a super Earth that's like or a sub-Neptunian object. For example, Saturn, it would float on water if you had like a super huge ocean, like way bigger than Saturn, with like 1 g of gravity. It has like a average density of like 0.7 something or 0.8. So it would float in water. Other planets like Earth, it has an average density of 5.5 grams per cubic centimeter, but it's not all one substance. Obviously, we know it has like a iron-rich core that's only so big, a size, and then you have the mantle and the asthenosphere, and then you have the crust, which is the only part we actually ever see. But the crust is, in relation to the actual whole planet Earth, is like the skin on an apple. Like, it's just a very thin layer. And so we are on a very rocky planet, so its density is that of rock, of typical rock, the average between all the iron and all the actual rock. And so you could look at that, and you could combine that information with what you get from looking at starlight that passes through its atmosphere. You could actually get a chemical imprint of what's in the atmosphere encoded on the light. And so you could start making guesses. Yeah, they are guesses, but they're educated guesses, and they're starting points for future missions and future observations that have much better technologies, more precise instruments to actually do follow-up. And in fact, the launch of the James Webb Space Telescope is going to revolutionize a lot of things. The James Webb is not in and of itself an exoplanet hunter, but it's one of the many things it's going to be doing. Also, it's going to be looking in infrared at the universe when it was very, very young, like shortly after the Big Bang. So it's going to do a lot of stuff, and you're going to just watch the news. You're going to start to see a lot of huge discoveries coming out with the launch of TESS this past March. You're going to start to see a lot of cool stuff happening, even more than Kepler's already found. Cool. I was just about to explain briefly the process you go through with how they know what they know about the first exoplanet, that hot Jupiter close in 51 Peg B. Crash course real quickly. Here's what you do. Assuming that the parent star is on what's called the main sequence, so there's like a timeline of phases in the evolution of a star that it goes through. And towards the end of its life, it does all this crazy stuff, and it could go supernova, it could turn into a white dwarf, all these exotic stellar remnants. But before all that, when it's just like it's just kicking and everything's just cool, like middle-aged star, and it's just burning hydrogen in its core, it's called the main sequence. So 51 Peg is on the main sequence, and if you look at its light, you could actually diagram, the Hertzsprung-Russell diagram, what its mass is based on its color. Essentially, you could do this. You could look at how much of the blue and how much of the red, and you could actually recreate a black body curve, and you can get the actual equilibrium temperature of that star, and based on that and some emission or absorption lines in its atmosphere, you could say where on this HR diagram it is. Now, on the HR diagram, when you pinpoint its temperature or its color index, you go down over here and you say, there's its mass. You got its mass. So then, just by looking at what type of light it's putting out, That's fascinating. It's such a powerful thing. There's so much information encoded in light. I mean, think about it. Even stuff like on Earth. Everything we know about everything, light. Unless you have a population of like humans that have never seen and they're like that, like their anatomy, like they just use Braille or something, then we would be kind of screwed in the sense that we wouldn't be able to learn about the cosmos or even terrestrial phenomena by all that information encoded in the light. So I guess it's a good thing that we have vision, you know?
That is wild to think about.
Yeah. Okay, so step 2, you know the mass of that star. And you know that light, sort of like it's the Doppler effect, you know, the pitch change is something. Sheldon did that on the Big Bang
Good
Theory.
at that.
Love the sound
Have you
effect.
been practicing that?
Yeah. No, not yet. We'll get to that soon.
Yeah.
Right. So the light from the star, it goes a little bit to the blue, and like everything is like compressed a little bit, and then it expands a little bit to the red end when it's going away from the Earth. Now I should have already said this, but so there's no like up in space, obviously, right? And so you just have like star there, billions of stars all over in our galaxy. And so there's no preferred direction. So some of these planets, or like their orbital plane could be like this, or some could be like that. It could be any orientation angle with respect to Earth, and our line of sight from Earth to that star system. If you're like looking off at this angle, and the orbital plane of that system is not very close to along your line of sight, you're going to have a hard time seeing. You're going to have a hard time discovering that using either the Doppler method or the transit method. There are other ways to do it that, if we have time, we'll get into later. In the case of 51 Peg B, it's pretty close to aligned with our line of sight, and so that's good. And you would expect if they're all randomly oriented, equally in any direction, you're going to see some that are aligned with our line of sight, and it's just a matter of doing the statistics. And you could find out that something like 2 to 3% of all stars are aligned properly, and the ones that are like perpendicular, so they're like the planets are orbiting like this instead of like this. This is good, this is bad. Because then the wobble is in the plane perpendicular to our line of sight, and you don't get that radial Doppler effect that you could see. And the transit method, which I haven't even talked about yet, darn it, is where literally you're just looking at a dip in the light. You know, is that one of the... No, that's not one of my slides. It's one of the hidden ones. So did you guys see in 2012 the transit of Venus? Or do you remember hearing about that? So
Yes.
There's these really cool pictures where you see like the disk of our sun, and then like this very clearly small black circle as it moves across, and that was Venus, and it blocked out its own share of the sun's light, and it's tiny. Like the sun is like this, and then Venus is like this little speck, but it's clearly resolved. You could see it, and it was equivalent to like a 0.1% reduction in the light coming off the sun, and a lot of people observe that. That's essentially what Kepler does. It is looking at. It looked at about 150,000 stars, and it just stares at them. And its primary instrument on board is called a photometer. It just looks at how much light. It just counts photons essentially, and it's very sensitive, and it can actually detect minute changes in the light that a star is giving off. Even if it can't resolve like the actual planet, it says, hey, this star is dimming a tiny bit, and you'll see a dip, like it goes down for a little period. That's when it's crossing the disk, and then it comes back up. If you see that same dip of the same depth sometime later, then you could start getting some confidence that you're looking at a planet instead of just like, I mean, it could just be a sunspot, you know, like the stars rotate, and whenever they have some sunspots on one side. They're just sort of randomly around. There could be like half of it without any, like as it's going into solar minimum. And then whenever it rotates one of those sunspots into view, granted the rotation rate might be a lot slower. It might be like our sun rotates once every, what was it? 11-year cycle, but its rotation rate is like a few weeks long, and then it's also differentially rotating. It's not rotating like a basketball, since it's like a blob of plasma. The equator rotates quicker than the poles. So there's all kinds of stuff that you have to take into consideration. And as scientists, we have a very high standard of evidence. We don't. We want to discover planets. We want to discover habitable ones. We want to discover life out there. But the only way to actually find the truth is to be true to the objective protocols of the scientific method, and to make sure that like you have the data that's been corroborated, and you can say with certainty, here are the properties of this planet. Here's how we know that. Here's our error bars. Booyah. And we got thousands of them and counting. That's
Booyah.
Science, son. That's science, son.
I feel like if you're saying booyah, there should be better names. I just feel like there should be better. Ken, is that something you can pitch to the scientific community? Like,
Please.
Hey, dudes, we need to make better names here.
You can't be like Peg Booyah. You know what I mean? now Jerry Booyah, that works.
Yeah.
There's so much. There's so much like I'm just sitting here listening, and there's so much to unpack in this subject that it boggles the mind how like yourself. I just feel like, how in the world is he just rambling this stuff off like it's nothing? I mean, these numbers, these figures, this planet, it's just so incredible that, number one, that we as humans are able to figure out stuff like that. I think that just, that goes a long way to the human mind. But all of this would be fantastic if space were a real thing. And we all know that it is not. So
I actually would like to ask a question that is sort of related, but sort of not. What are your thoughts on astrology?
Astrology is it's a fake, like it's a game you play when you're like you're on a bus or a plane and you ran out of crossword puzzles.
I asked because you know how people talk about like the alignment of the planets and all this other
retrograde,
shit, Saturn
which are so annoying. Yeah, I hear that stuff all the time, and
it does nothing.
I like to think that they're just doing it for fun, but there's a lot of people that are like, yeah, man, like Mars is in retrograde, and I got a headache, and I'm like, well, now I have one too. Thank you very much.
My IQ's in retrograde.
But like when Mars is in retrograde, that doesn't cause headaches.
No. I didn't even know if that was one of the things, because I don't follow the.
I don't do astrology either. I just saw somebody in the chat mention it, and I was like, that's in relation to planets. Like,
yeah, I'm sure there are people talking about that in the chat. So gosh,
I mean, I don't think like any. I don't know. I've just, somebody said astrology is a prediction. Mercury is in retrograde right now, and that was your cousin that said that. I'm just saying. Yeah,
so it's true. Retrograde is a real thing. It's just has no consequences whatsoever on anything like on Earth. It's just it's actually an optical illusion in a sense, because what you're seeing is let's do Mars. It's easier. Exterior planets are easier to visualize. So because it's further from the sun than Earth, it goes slower around the sun. So let's suppose that, and we're all orbiting in the same direction, right? Counterclockwise when looking from like above Earth's North Pole, but way above it. And so the Earth will catch because it's going fast. Think like a race going around the bend in the track. And so the Mars will appear from night to night to be going a certain direction with respect to the background stars, which are for all intent and purpose stationary because they're so much further away. But those actually are moving. It's another topic. And you can measure those motions of the stars, not with your unaided eye, though. And so once Earth catches up to Mars, then it overtakes it. And so, but Mars is still going in its orbit roughly the same speed it always was. And so now now Mars is now on a night-to-night basis. Mars is in the sky going backwards, right? So it does these like loop-de-loop things.
Oh yeah, I see.
And so that's all it is. Like, so yeah, we got planets at different radii, and we're going around the same
That's how we get
direction.
headaches?
Different. No, I just brought that up as a for instance.
Isn't retrograde one of the ways that we figured out that we are not a geocentric, like that we're not geocentric?
Yeah, absolutely. Mm-hmm.
I would ask Dr. Robert Sungenis about that. If we were, he's a geocentrist. It was a joke.
Oh no. Okay, sorry. I didn't mean to like off track, but like I saw people talking about it, so I was like, let's just get it from the expert. Astrology is bullshit. Doesn't have shit to do with planets.
Yeah.
That would be a very profound conversation.
Different, yeah. I like what you did there, Dave. There's so many different directions that you can, like sitting here, I'm literally writing down all of my questions, and I know that we're not going to get to many of them, but I'm trying my best not to mess your flow up. But there are some questions where I'm like, oh, ask him about Diamond Planet.
Okay. Actually, last place I left off was we're still at Peg 51 Peg B. I'm almost done, I promise. This is just such a prime example that I'm almost done there. So we discussed how we figure out the mass of the star, pretty much just by looking at it and finding on the HR diagram, and by looking at the type of light it's giving off. And then now that we have its mass, and we don't know the mass of the planet, but we do know its period, because we know the period of the wobble of the star is going to equal the period of the star, or of the planet around the star, just different amplitudes, right? So you could calculate the mass of that planet by determining how big of a wobble is caused on that star. Think of like gravity. It's a two-way street. So like the star is causing the planet to go in an orbit, but give the planet some credit too. It has mass, and in this case a lot, so it's tugging on its parent star, and the more massive that the planet is, and also the less massive that the star is, the greater this wobble will be. So when you look at a sine wave where you have all these data points that you've measured night to night, and you look at the amplitude of that sine wave, that's going to correspond, it's going to be proportional to the mass of the planet. And then the distance that the planet is from the star, from Kepler's laws, based on the fact that it's how long its year is. So boom, just by looking at light and how light is red and blue shifted, we calculated the mass of the star, and as a bonus, like its temperature and spectral class, assuming it's on main sequence. We calculated the mass of the planet, and we know its distance from the star, how long its year is. And if you do follow-up campaigns using the transit method, which I'll get to in a moment, you could know the physical size of that planet. And then now you know its average density, and now you know something about its composition. Boom, done. So that's pretty, so instead of booyah, I'll just say boom.
I like booyah, though.
Okay, we'll do both. I'll alternate.
Booyah, boom.
So there you go. That's the question.
There's actually a question in the chat from Main Gun. What is the largest orbit of an exoplanet so far?
The largest orbit, that would correspond to the longest time to go around. I think I saw one that was a few hundred days. Similar. It was either a little bit less or a little bit more than our planet Earth. The thing is on the other end of the spectrum, when you get to planets that are, even if they're relatively massive, and they're really far away, they have these long, like huge orbits, the gravitational tug will be small, so they're going to be harder to see because the star won't have a lot of wobble. And if you're using the transit method, the angular size of that planet is going to be smaller when it's really far away, so it's going to block out. You can still find them. I just don't have those particular numbers specifically off the top of my head, but I saw something like that.
Let me ask you a question along that similar line of questioning that I had written down. We're actually doing a show on this in 2 weeks specifically, but what are your thoughts on not Nibiru? Let's clear that out, but the possibility that there is a Planet 9 out there, not the conspiracy Planet 9, but the the one that they're thinking might be out there?
Well, yeah, I would just say show me the data, pretty much, because otherwise it's just guesswork. And I have heard about what you're talking about, and I didn't look specifically into any data. I don't know if we have any, but that's all I can say objectively. It'd be surprising if there were something that was like an actual planet as sizable, comparable to Earth, and we hadn't seen it after all this time. I mean, we found some Kuiper Belt objects, which Pluto is a member of, I believe. I think Pluto is more of a trans-Neptunian object, but like Ceres, I think is one of the Kuiper Belt objects, and Make, they're like these really small, they're like big ice moons almost that are part of the Kuiper Belt, which, if you don't know, it's like the asteroid belt, only it's mostly icy bodies, and it's further out than Uranus and Neptune and Pluto. And then there's even, as a bonus, Make, spelled like make me a pizza. So I don't know why I just went there, but
you know what though? I'll never forget it now. Yeah. I will never forget that now.
So then there's this Oort cloud, which is much further away, and it's spherical, like around our solar system. That's like where the comets come from, and they're mostly icy, rocky chunks of debris left over from the formation of our solar system. And so there you go. Where was I going with this? Anyway, what was I talking about before?
You were talking about, you were getting ready to go into the other method, the
transit.
Yes, transit method.
Right.
Yeah, thank you.
Okay, cool.
Where did I go?
So this one doesn't involve nearly as many physics principles, like I was talking about Doppler shifts and wobbles and spectra and all that cool stuff. The transit method.
Oh yeah.
Yeah, I don't know.
What happened?
I think we just lost KC.
Yeah, is this okay? I don't know what happened, and I'm not the techie person, and GE's not over here. Okay. I think I got it.
You're back now, I think.
Sorry.
You're back now.
Sorry.
Cool. So yeah, the transit method, which is what Kepler uses, is just like I said with the Venus thing, looking as the planet crosses the disk of the star and watch for little dips in the amount of light that star is producing, and see if they periodically happen. Then you could calculate properties of that planet, and similarly you can get its size more easily from this method, and with Doppler observations you can get the star's mass. And so let's see, what do I got here for you? So I have on slide 12. We could look at that, please. Slides.
Godless Iowan just said I fell into Uranus.
Guys.
Nice Godless Iowan. Nice Godless Iowan. Touche. Yeah. And you won't see it on your end, Dr. Croon. Okay. They'll be able to see the slides up.
All right. So I didn't anticipate as much, but I do have a second chart that we cannot see that's behind it. That's my bad. But so what we're looking at here is as a function of like year, like what year we're looking at. The blue bars are the radial velocity, and the green is the transit method. And you could see on the vertical scale there, you're looking at 110 in 2010, and then it dropped down in 2011. Sorry, hiccup. But that's probably just due to what's called a data dump, where you get like just a ton of data, and scientists are scrambling to, because it's a lot of work. It's not just like the Kepler beams down like a bar graph. You have to do statistical analysis. You got to calculate a lot of stuff, a lot of data reduction and analysis, and sometimes colleagues that you're working with on that data set will come in and double check your work. And then, of course, there are follow-up campaigns for a candidate planet to actually become a confirmed exoplanet, and it gets added to the database. But
that's what infuriates me about flat earthers, that they don't understand that all of this amount of work goes into, like, there are people who literally just, they're doing this all day long, and all of the data, like you were talking about, and you think about each individual piece. Not only are you talking about the data that comes from the planets that we have in our solar system, or the probes that they have out there, or trying to track asteroids and comets, but even things like this. I mean, that's a pile of work that people are sitting there doing, and they just dismiss it by saying gravity's not a thing and space doesn't exist. There's a tent that God stretched over the planet, like called the firmament. The waters above from coming back to the Earth. It's so stupid.
Yeah, I've written papers. I'm on number 5 right now. I just submitted it a week or so ago to the Astrophysical Journal. My second and last paper as a postdoc, as I near the end of my contract. And it's a lot of work, and it's phase 1 is like doing all the calculations, and then you got to write this very professional, formal report, version, revision after another, and it's just the general public by and large doesn't appreciate the work, how much work any scientist does in his or her field, and so it's kind of silly when people say stuff.
Debates. Why did you do that to yourself?
Well, it's a good question. I had to figure out why I was doing that. First, there's like a little bit of a sense of amusement. It's sort of just like hearing what they would call an adequate answer to a question you pose. Most of the time, they don't even address at all what you ask. They're like, "Oh, but this other thing." It's like, you didn't answer my question. You didn't even come close to the same topic. So it could be, it could be a bit frustrating, more so for you guys on the show than me just, chopping onions and making curry, which I do a lot, by the way. I love curry. I cook it like this every day.
I have a couple of questions from the chat, if you don't mind.
Sure, go for it.
Puffalopagus 360 wants to know, how likely is it that Triton is a Kuiper Belt object?
Triton is one of the moons around Neptune, I believe, and we're pretty sure it's you could see it orbiting around Neptune, and so I think we're pretty certain about that. I think that girl is Puffalopagus. That was one of my friends from college. I think
it's a guy.
It's a dude. A guy. Different.
Yeah.
Oh, I was thinking of Snuffleupagus.
Oh yeah, no, Puffalopagus.
Did you?
Oh, okay. Yeah.
Do you have a party out in full force in the chat? That's cool.
I have another one. Okay, so shit, where did it go? It was a question. Damn it. There it is. What exoplanet is the closest to Earth in light years that may be habitable? Yeah,
so Proxima Centauri b. It was also referred to in the media, like a little article when it was discovered, as the Tatooine planet. It has 3 suns in its sky, and it was resembling, it conjured up images in your mind of that Star Wars planet Tatooine. And so Centauri b is by definition, the absolute closest planet to us in general, even the closest star system to us. And there's still some debate going on as to whether or not it's habitable, because it's with a really small star like the one it's orbiting. Out of the 3, by the way, you have 2 stars orbiting really close, and then one way over here that's orbiting the binary. So you have a tertiary star system, and the Tatooine. There's a Casey, you were talking earlier about getting better names. That's a pretty cool one, although it was like stolen or borrowed from something that was already named.
I don't like Star Wars. I don't like Star Wars.
Okay.
I'm a Star Trek.
Star Trek person.
Oh.
Let me ask you, when you talk about the something like that has 3 stars in it. With our solar system, we revolve around 1 star. Is the planets revolving around like the 3 of them as a group, or one particular star?
Yeah, so
in general.
Yeah, so if you look at the equations of motion for an in-body system, the math gets extremely complicated, but more so it becomes highly unpredictable. But what we do know for sure is that if you are in a 3-star, or heck, even a 2-star system, and you are just one planet, forget about multiple planets in that system, there's 2 solutions. You could either orbit really close to one of the stars, so you're like sort of like the gravitationally dominated by just that one star, and then the other one it's there and it's part of the system, but it doesn't influence your orbit very much. If at all, assuming you're in a stable, like let's say circular orbit, pretty close to that star, you're locked in, you're fine. And it could be either star, and there's nothing special about one or the other. Or you could orbit the whole system like way far away. So the Gauss's law, and the way that gravity works, it always seems that the force acts as if it's directed directly to the center of mass. So if you have 2 stars, let's say equal mass, and they're going around each other, and you're a planet way over here, whatever the mass is of both of those is going to be the mass that determines like how fast you orbit around, how long your year is based on your current distance, using Kepler's laws. And so those are 2 scenarios where you could have a stable orbit. If you're somewhere in between those 2 extremes, you'll get these weird figure 8s and all these polar, and it's unstable. And you could be thrown. Yeah, but you wouldn't last very long. The planet would be eventually ejected out of the system, or something like that. And those are called rogue planets too. There's a bunch of those that we're trying to find too.
I was thinking like if a planet orbited, one of those stars, like let's say you had 3 planets and they were each circling, 3 different stars. If they were close together, it seems like at some point they would crash into each other.
Why?
Because if you have like the 2 that you're talking about were really close, if the 2 stars that you were talking about that were kind of close had planets orbiting around them, at some point it seems like they would meet.
The stars.
No, the planets. The planets that are rotating them
around one of the stars.
Yeah, if you have a planet that's rotating around each star, so they're spinning.
Yeah.
You have a planet spinning this way and a planet spinning this way. Seems like they would probably meet at some point, at some intersecting point.
Yeah, if they were to get close enough for that to happen, you wouldn't have a stable orbit, I don't think. So that would preclude us from ever observing something awesome like 2 planets smashing into each other. Darn.
That would be cool. That would be pretty cool.
That would be cool. I do have a few more questions.
Sure.
Okay, so how many Earth-like planets are there in our solar system? Like just our solar system? Oh, no, I'm sorry. Our galaxy.
Oh, okay. I was gonna say 1. We know the answer.
My bad. It's been a long day.
It's fine. So, I would say dozens to upwards of. I don't have an exact number. I think it's like 100 and something or 200 and something that are in the habitable zone. Well, hold on. Hey. Like that's just from the Kepler, right? And TESS is going to look at 250,000 stars instead of 150,000, and they're all different. And it's predicted that it's going to discover 10,000 new planets in general and about 1,000 Earth-like planets or planets in the habitable zone. So we have hundreds out of the several thousand that Kepler has found that are in the habitable zone. But then you have to say, is it a gaseous planet or is it a terrestrial one? You want the terrestrial one so you have a surface and whatnot. So then the numbers go from thousands to a couple hundred, I believe. But it's just the numbers are going to keep growing and growing the more we look for them.
All we need is one.
Yeah.
Steve McCrae, our lovely non-sequitur co-host, has a question. Has the 3-body problem been solved? The 3-body problem, is that a thing?
Yeah.
Has it been solved?
No. Well, yes and no. You could do numerical solutions. It's a differential equation that doesn't have what's called a closed form analytical solution, but you can't. I mean, yeah, you could solve it. You could do a numerical solution to the differential equation. But the problem with the in-body problem or the three-body problem is that it's always highly chaotic, and chaos to a scientist means something different than it does to a layperson. You hear chaos. Kyle, let me ask you, what do you think when you hear the word chaos? I'll just go about it.
The show.
This show
in general.
Okay.
Okay.
See, there you
go. Not this
Fucking
specific
Twitter.
show. Not this specific show. But just the concept of. But no, chaos. Out of order, disorganized, not in a orderly fashion.
Okay, sure, and that is one definition. But in this context, chaos simply means it's the evolution of that system is highly sensitive to the initial conditions. You could literally see this with a double pendulum. Like you just take like a pendulum that can only swing left, right, and then you hang another one from below at the same length and same mass, and then you like fold them up and then rotate it at 90 degrees and just let it go. And you could have like a little dot at the end of each one, and in a dark room with a camera following it, and it'll do something that's very similar to what it did the last 10 times you dropped it. But then after just a few seconds, it starts doing like something completely different, and it's in a different state. And so that's the reason why weather is hard to predict. Like we could predict the weather with 100% accuracy 1 second in the future, 5 minutes, probably even an hour or two, and then the further you go, a few days, maybe you're like 50 to 75%. A month or two, forget about it. Because there's no way to know infinitely precise the current conditions right now. And so these tiny differences in the initial state will blow. We call them blowing up into something completely different. It's the whole butterfly flapping its wings, which is something that you didn't take into account because it's so small and nuanced and far away. And then over time, it could have a drastic effect on your system. Yeah.
Okay.
Good question.
So another one is, when will we start hearing about discoveries made by TESS? Are we already receiving data?
So yeah, data is coming in. And scientists are looking at, probably even as we speak, there's someone like typing away on a computer somewhere. I would say, answer your question. There you go. I would say start looking this winter. You might have some preliminary reports coming out on what they're seeing in the data. Like it's a 2-year mission, and it's going to observe 85% of the sky, whereas Kepler only looked at 0.25% of the sky. So
wow, that's
Kepler
amazing. You guys are going to be busy till you're dead.
Yeah, Kepler stared mostly along the equator, the ecliptic, like around the galactic plane of the Milky Way, and just an area roughly the size of 2 Big Dippers, I think even just the scoop of the Big Dipper, and then and looked at stars and planets as far as like 3,000 light years away, and TESS is going to look at almost every part of the sky, all around northern and southern of its hemispheres, from its vantage point, and not as far away. And it's going to look at more stars. It has 4 cameras. Actually, I think I have a slide for this. If you go to and then slide 14, please. I think we'll see something. We'll see this diagram here, which I pretty much just said, but it's essentially a 200 light years radius search for TESS, compared with like 3,000-ish from Kepler. So it says all sky, but it's like 85%. And what it does, it has 4 cameras, very sensitive cameras, and what it does is they're positioned like this, like one looking straight out, one up a little bit, a little higher, and then one that's actually all the way straight up. I don't want to break my finger. That like straight up, out, and then 2 in the middle. I could for the show, but maybe next time.
No, let's not. Let's not.
And so it stares at those, and it rotates over, and there's a little bit of overlap, and then it rotates again till it's gone around. And so the camera that's always looking up, it's looking there the whole time. So you sort of get a redundancy there, and then the 2 in the middle and the 1 on the equator get to look at new stars as it rotates around. And then it does that for roughly a year, and then it switches to the southern hemisphere and does that systematically. It goes around, and also has an orbit that's pretty interesting. It's out of phase 90 degrees with our moon, and inclined significantly, like 20 some odd degrees, and it has an orbit that goes out like a million miles or something, 100,000s up to like a million or so. I wish I knew the exact number. Wikipedia has an excellent animation. If you're listening to the show, just go to Wikipedia, type in TESS, the satellite that's looking for exoplanets, and there's a little orbital animation on there.
Does it have a selfie cam? That's the question. Does it have a selfie camera?
Yeah, can it look back at us?
That's what's coming up. We're looking forward to that.
Oh, we missed your answer because it froze. Does it have a selfie cam?
I said no.
Oh, damn. You know, it's because the Illuminati doesn't want us to know the Earth is flat. That's why. I'm just saying.
Yeah.
If it can look at 85% of the sky and it can't fucking look back at us, then they're hiding something.
Oh, absolutely.
It's obviously because it's flat. Now, we're at the we're a little bit over the hour and a half mark, which is crazy because, like I said, all of these talks always go quicker than the other shows do, because they're more enjoyable. But I did want to hit on the Drake equation because you talked a little bit about that, and I'm interested myself to know what those possibilities are.
Absolutely. So let's see here. I think I have a slide for that.
Oh, I think he froze again.
Slide 39. Could you hear me whenever the video freezes?
39. Yeah, we got you now.
So essentially, the Drake equation is a series of increasingly restrictive parameters that ultimately lead one to estimate the total number of communicating intelligent civilizations in our galaxy. You could conceivably apply it to the whole universe, but since galaxies are so much further away, and we're having a hard time even seeing ones inside our own galaxy, practically in our backyard, we're not even looking at like the planets on the other side of our galaxy because the core is in the way, So this is just for our galaxy for now, and we know roughly a few 100 billion stars in our galaxy, and then it's so that's good. Then you multiply that by the star formation rate, which is about, so that's the first term, R star, the rate of formation of stars, and it's something like 3 to 5 solar masses of stars are formed every year somewhere in our galaxy. Now, that doesn't mean 3 to 5 stars. That just means that 3 to 5 times the mass of our sun. So small, like red dwarfs, they could have like 1% to 10% of our sun's mass, or even less than 10%. And you could have big O stars, like hot blue and white stars, that could have 10 or 30 times the mass of our sun. So it turns out that star formation prefers the smaller stars. There are way more small red dwarf stars than there are a giant O or B star. It's just a little bit easier for that gravitational collapse to grab onto some dust and gas and make a smaller star. So I said about 10 stars per year, let's say. If we say like the lower end of 3, let's be pessimistic, and then maybe it's about a third the mass of the sun each on average, and that's about 9 or 10 stars a year. And then FP, the fraction of those stars with planetary systems. This right here, we've started to measure directly with the Kepler mission and everything else. Turns out planets are exceedingly common. And so that's a fraction between 0 and 1. And you could say 0.9 or 0.99. And so then NE, the number of planets per solar system with an environment suitable for life. So that's related to, what is life anyway? Like we have extremophiles. You guys hear about these like microorganisms that live near like really hot vents at the bottom of the ocean, or in high radioactive, like in Chernobyl, like wherever, even if it's like highly acidic or really hot or really cold. I'm sure it's microorganisms, but it's very amazing the biochemical skill set that these little bugs can evolve with to thrive in these harsh conditions. So you might want to consider that when choosing a number for that box there. And then FL, the fraction of suitable planets. Remember, if it's in the habitable zone, if it's suitable for life, it doesn't necessarily mean there's life there. Maybe it hasn't developed yet. Maybe it won't. You never know. For example, life got started on Earth like almost as immediately, as soon as liquid water formed. The oldest rocks we have show fossils in them, like 3.8, 3.9 billion years old. Solar system is like 4.54 billion years old, but maybe the first half billion years, you still got lava ball planets. Yeah, they haven't cooled yet. So life seemed to start up very, very quickly as soon as liquid water.
That's crazy to think about.
Yeah. Where was I? The fraction of those planets where life actually appears, any type of life, and it might even be quite alien. Then FI, the fraction of life-bearing planets which develop intelligent life. That one's that's interesting, because if you look at it, it wasn't until very recently. Yeah, so life was perfectly fine for 3.5, 4, pretty much if you start humanity 50,000 years ago, 100,000 years ago, the earliest humanoids, we just showed up, and life was perfectly fine. It doesn't seem that there's anything, unfortunately, it doesn't seem like intelligence is something that is like an end game, like something that's evolutionarily necessary. But it does happen. There were intelligent.
We get it, and then we get it, and then some of us decide to just throw it away. I think it's a. But my question would be, what would you consider like their definition or standard of intelligence? Because if you have things like dolphins, dogs, I think that could be like animals. I think have a sense of intelligence, like they're able to do. Or do they just mean like human intelligence, or just animals that can think through things?
I think he's frozen.
Well, yeah.
I can't hear him anymore either.
Are you there, Dr. Croon? Dr. Croon?
Hello? Oh, there he is. Oh.
Am I back?
Yeah.
Can you hear me at least?
Yeah, we can see you now, too.
Ah, okay. Yeah, it still says poor network connection, so I might be...
Yeah, I think it's your
What did you guys hear? I was talking about, I'm on a landline. I got gigabit internet too.
Going out on you.
This is not cool. I got gigabit internet, and I'm using the landline because the Wi-Fi signal's weak. But it looks like I'm back. Am I back now?
Yes.
I would call and bitch out your provider and get a free month.
Yeah. I'll do that.
Be like, I was doing a lecture on the internet, and this shit fucked up.
Booyah.
Yeah. So intelligence, there's a lot of animals on Earth that are far more intelligent than we probably give them credit for, and smarter than some people, possibly. And so you could define intelligence either way. For that little box in the Drake equation. The next one is the fraction of civilizations that actually develop a technology that releases detectable signs of their existence into space. It's probably going to start out as like radio waves, like some form of electromagnetic waves. So like think of like human history all the way up to but before the 1890s or whatever, when the first like radio was starting to be developed. Like we were perfectly fine as humans with civilization, with cities, and trade and all this stuff without actually communicating electromagnetically. Well, so it took us some time to figure out the physics and start making technologies.
I don't know if you saw that new article that they have in the Journal of Applied Physics, but they this is true. This is not a joke. Somebody sent it to me over Facebook last week, and I think because I have I subscribe to a certain and it's not as crazy as like people. I get so much crazier shit because I think that civilization is older than they say it is. But like he sent me this article from the Journal of Applied Physics where they had recently discovered that the pyramids channel radio radio waves, and there was something else. But in the chambers, it channels it like a perfect V down into the center of the pyramid. So that's strange.
Yeah.
Right?
I saw something like that, but I didn't click on it because I thought it was clickbait. But now I wish I took a peek.
Kyle, your shit is clickbait.
Listen, I'm gonna be honest with you. I thought the same thing when he sent it to me. I saw the title, and I never got into the whole the pyramids were used for like centers of like those kind of things. I never got into that, and so when I read the title, I was like, man, he thinks that because I think that the Sphinx is older than it is, that I subscribe to all of these different. We had Wi-Fi obelisks and all those other kind of things. So I just clicked on it because I didn't have anything else to do, and I was reading. I was like, "Whoa, this is from an actual scientific journal, not a joke."
Right. Yeah. So yeah, the last term in this equation is L, the length of time such civilizations release signals into space. So that's essentially saying how long what's the lifetime of a civilization. Now I would say it's different for everyone. I guess not probably like like they blow themselves up, or maybe just the star spits a huge flare and sterilizes the planet, or a comet or something takes them out, or zombies get released, or a nuclear holocaust. Probably
zombies.
Probably zombies.
So it doesn't necessarily mean. Like a civilization, like the Mayan civilization or the Roman, like those were the humans, but that was a civilization. The Earth didn't get wiped out; it collapsed. That civilization collapsed, and there you go. But in this case, I would imagine they're referring to the technologically advanced civilization that's sufficiently advanced to just even have radio technology or something like that they would send out into space, whether they meant to or not. Like there's, like TV broadcasts from like the 50s or whatever, still going out through space, at the speed of light in every direction. And we didn't like broadcast them intentionally as like a message to aliens. It's just when you're broadcasting, light's gonna do what it's gonna do.
That's wild.
Yeah.
So what do they come up to? What's the
right? So I have on slide 39. If you go to slide 39, were we on 37? Yeah, we got to go to 39. So the thing is, you type in your own numbers. It's sort of like a simulation. It's fun. It's fun for me to think about these things.
I got you.
I'll do this while eating cereal in the morning sometimes.
What do you put for the last one, though? Just curious.
So I
what
put.
do you put for that last
So
number?
on this one, I tried like 300 years. That was like a really short one, and then you could also have one like 3,000 years. I don't know if you go back to like human history and look at the shortest and like the longest living ones. So I did. There's one behind this that we can't see because it's animated, but I did it for 300, and then I did it for like 1,500 years or something. Mm-hmm. And you get different numbers, obviously. But so I chose 5 stars per year. I was pretty optimistic about the number of planets, 0.99, because almost like pretty much every star we've seen has at least one planet. NE, so the number of planets that are suitable for life, I just put it at 1, just for giggles. Action of planets suitable for life that actually have life. And then I was pessimistic about intelligence arising, so I put 0.1, and then 0.8 for intelligent life that develops telecommunication technology, and then a 300-year, the lowest possible thing you would imagine for a civilization lifetime. So you get 120 civilizations other than Earth. And it even tells you the average distance to the nearest civilization, assuming they're like evenly distributed, averaging out to 4,600 light years. So we found tons that are even closer. So, take averages with a grain of salt, as they say. But it's a fun little thing. On the previous slide, Yeah, by the way, on the previous slide, I put the URL at the top if anyone watching wants to go play around with that. And you could type in your own numbers and calculate different. Now, keep in mind, though, if any one of those numbers is exactly 0, then you cannot, that all equals 0. But we know that not any of those terms can be 0 because we exist, right? So it makes you think. So they might just be really small. And then maybe there is only one civilization like humans in our galaxy, or maybe there were, but now they're all dead, or maybe they haven't come into existence yet, maybe like in the future. Because remember, you have to not just think about space, the space of our galaxy, but time, all the billions of years past. The Milky Way, I think, is like it's 10 or 12 billion years old. It's just a little younger than the universe. There are stars, plenty of stars in our galaxy that are as old as the galaxy itself. And
I break my brain thinking like that, like just
how much time to play with here. So there's things to consider. It's pretty fun.
It is a really cool thought experiment. A really cool experiment.
Just to think that there's like if your example was correct, and there were 120 planets in this vast solar system that had life on them, like that is crazy. Like just wrap your mind around that. And we had this talk too on the in our test call about because I had asked you where space ended. There's just so many different. What frustrates me is that we'll never have the answers to these questions. Like we'll never know if space ends, where it ends, what's at that ending. Like how far out does it go? What's out there? Like it's frustrating that we can't get the answers to those questions, but we can. We have an imagination to be able to think about what the possibilities are. So it's kind of a tease.
There was another question that was asked a little bit ago, and I know we have some super chat questions too that we might want to get to. But this one was, and I forget who asked it, so I'm sorry. But is there a possibility that tachyons exist?
What is that?
Possible. So tachyons are hypothetical, not theoretical, hypothetical particles that travel backwards through time. What that would look like, I don't know. It's one of those like sci-fi concepts that we have no like direct evidence of. I don't even know how you would like observe, like what would that look like, even tachyons, a particle moving backwards in time. I don't know. I don't think anyone has any evidence to say one way or the other on tachyons at this time.
Breaks my brain.
I get it at this time. I just said that.
Brain broken.
Yeah.
Dave, do you want to read the super chats since I don't have those up?
Sure. Let me get to those. Let me grab them real quick.
I'm on my. Go ahead.
While he's doing that, there were a couple people. One person asked, where can they read your papers that you were talking about earlier?
Oh, yeah. Okay. So if you go to archive.org, it's spelled arxiv.org. It's a Cornell University publishing database. And you can just type in the name's Kroon, my last name Kroon. And then also type in Becker, Becker. He's my primary collaborator, colleague, and he was my dissertation advisor in grad school. Because there's, I guess, a bunch of other Kroons out there that will narrow your search result down. You could also go to the Harvard abstract search query called ADS. It's adsabs. I'll spell that in a minute. adsabs.harvard.edu/abstract search, abstract_search. Adsabs is spelled A-D as in dog, S-A-B as in boy, S. Adsabs. It's the ADS search. You could find them on there too.
If you want to send that to me, I'll put it in the
links.
Yeah, I could send them.
Yeah.
Mm-hmm.
That way we can make sure they're in the description and people can go see that. And then someone else asked if you have like a YouTube channel or anything like that, any kind of place where people can see you.
Look at that grin.
I have like 5 videos. Don't watch them. You might be a little bit confused as to what I'm doing.
I say the same thing.
I think everyone's gonna watch them now. But I have a few videos. Also, well, that's pretty much the only thing. I mean, I have a Twitter account, but I log in only once a year.
Oh, that must be. I don't even know what that would be like.
Why even have one?
I don't know. I think it's so I could follow Neil.
Oh, okay, that makes sense.
And because like he's so cool, and I like his. I only read his tweets pretty much, and Bill Nye is on there, and Michio Kaku. I follow those 3 scientists. I have Facebook, and I only use it to post science articles and astrophotos. I do astrophotography. I just started that. You could see my photos on AstroBin. Go to astrobin.com. /users/physics_guy22. That'll take you to my gallery. I have like 17 pictures up. I took myself with my own gear, and I'm still learning. I'm growing quickly though. I'll send that link as well. So I've been posting those on there, and that's about it in terms of finding me. Yeah, cool.
That's awesome.
All right, we got super chats ready.
Yes, we'll link all those too in the description as well.
Okay, so first one was actually 2 questions from 0132132. Thank you for your donation, sir. Will we ever be able to detect exoplanets in other galaxies?
Actually, I'm sorry. Was there?
That's the first question.
Okay.
Yeah, go ahead.
Okay, so I would say yes. I think we already have discovered one. I don't have the details, but we used gravitational lensing to find a planet in a nearby galaxy. Google it. I think you'll find more information than I have on the top of my head right now. Sorry about that.
Awesome.
Okay, cool. And his second question was, are there well understood means of searching for exomoon?
Yeah, it's called micro lensing. Actually, that's a technique used to what it is. It's like how light bends around the gravitational well of a planet, and it actually lenses it, actually magnifies it, and so it'll if that planet has a moon, you'll see a bump on your spectrum from the planet, and that's going to be small, and you'll see a tiny one for the moon. So you could use that method, or even in some rare cases, a technique called direct imaging, where you sort of like block out the light of that the star, and then you can actually take a picture directly of the planet, which has been done before. I didn't put that picture in here though, but conceivably, if the moon were big enough, you would be able to see it in that picture as well if you had a really good sensor, high resolution.
Excellent.
Mr. STR, I am not going to read this one on air. It's a joke. It's a little bit in poor taste. I'll leave the super chat up. Whoever wants to review the stream could go back to 828 and read it. You can go back to 828 and read it, Kyle. It's not horrible. It's just in poor taste.
We'll read it off air.
And then Prodigy FX, thank you for your donations, by the way. Will the James Webb Telescope be able to find exoplanets?
Yes, it's going to be really good at that. It has a very sensitive infrared detector on it, and one of the cool things about that is you could look for planets by looking at the heat they generate. The day side of the planet will be warm, will be hot, especially in the case of the ones that are a little bit too close to their star. And so whenever it's revolved around in its orbit, so it's like 90 degrees to our line of sight, you can look at the infrared heat that it gives off, or even on the night side, if the rotation rate is fast enough and it's not like a tidally locked system, you would conceivably still get infrared signal from the night side, and it will be able to detect those as well as transits if it gets enough time on such campaigns.
Okay. The next one is from Tovark for £10. Thank you for your donation. For Dr. Croon, as someone who is enrolled for a Bachelor's in Science in Astronomy and Planetary Science, Are there any words of wisdom you can impart for aspiring astrophysicists like myself?
Good question.
Oh yeah, absolutely. I would say get involved. Go to an observatory. Go to a star party. There's probably star parties in your area, or a short drive away. If you don't have an actual observatory associated with your educational institution, you'd be surprised how much you learn, and even possibly find mentorships from people there that are more advanced that would like to do one-on-one or two-on-one, like little, learn. They'll show you through the telescope they have and show you how to use it and all that stuff. That's probably the most practical way. You can also watch Neil deGrasse Tyson on Cosmos. They're coming out with season 2, by the way, in 2019. I can't wait. So that's always very informative, and it's really put down, like the cosmos are like really just down to earth, like right here, so accessible. It's a really fun way to learn. I always say, I've shown my students clippets from that show as well. So yeah, just get involved, buy a small telescope, learn how to do it, and also incorporate it into your daily life. Don't just think like, okay, astronomy just during class or homework or at a star party. You go out and you see the moon is up in the middle of the day. Think about, how what's going on there? Where is it in its orbit? And think about phases. Astronomy is all around us. It's not just in textbooks. It's a lot of learning opportunities there.
What is a star party besides a party that Casey and I attend?
What?
I was making a joke about there's only parties when Casey and I go to them. So
Yeah.
What star party do you go, sir?
Right. So the next
Go ahead,
one
Dave.
was from Preaching to the Tire Ministries, which is kind of ironic. Wonder who this could be from. It's $5.
Well
God
played.
bless you all. Have a good year. So I wonder who left that preacher, Preaching to the Tire Ministries. I wonder who that's from.
That's funny. Funny.
Zombie Robot Sheep for $10. Thank you for your donation. Great show. Love this topic. Looking forward to part 2. And I believe we already answered this. Does he have a channel to follow anywhere? Can we put the link into that? Link to that?
Yeah,
in the
I'll get all
description?
this from.
Yeah.
I'll get all this from Dr. Croon when we end, and I'll update it.
From Puffalopagus 360, $2. Thank you at Steve McRae. Not sure what he's thanking Steve for. I might be in on that, Steve.
Who is Steve?
Who the hell is Steve? I don't know.
He doesn't.
I don't know.
He doesn't exist.
It doesn't exist.
Steve McRae?
Last one. Dirk Diggler for $5. Dr. Croon, why do you prefer using a small 2-stroke generator when observing the sky? Not sure where that comes from. I don't know what he's talking about.
A 2-stroke. Oh, wait. He said, why don't I prefer?
Why do you prefer?
Using a 2-stroke generator? I don't have a generator, but my friend does, and I think I know who asked this question. But I would love to use one, because then I don't have to haul out my large deep cycle marine batteries, and they're heavy and they take forever to charge. I've actually been thinking of getting a 2-stroke generator and using that whenever I go out to a remote site, so I can pretty much just image all night, because my battery actually dies after 4 hours. So I got like a couple of them. It'd just probably be easier to power everything from a Jenny. Probably be getting one sometime.
And then the Godless Eye one just put in $2. Uranus. Uranus!
Well, thank you, Dr. Croon. We obviously will be setting a second date to continue with this. If you decide that you want to come back, of course. If continue on that. But
you should come back. You should come back when Steve's on, because Steve would love to talk to you about this shit.
Yeah, I would love to talk to him too.
So, what was I going to say? Oh, yes. At the beginning of the show tonight, I didn't. We jumped straight in. I forgot all about doing the upcoming shows, but the main one that I wanted to kind of talk about is the one on Tuesday. And yesterday, if you remember, Steve and I did a kind of an impromptu discussion about freedom of speech and the Alex Jones situation of him getting banned. And Alex Jones's ex-wife actually tweeted at us. Yes. And so we have talked to her, and she will be joining us on Tuesday at 8 p.m. Eastern. And we will be learning all about the real Alex Jones, what he was like, the behind-the-scenes stuff about the custody dispute that he had, just from somebody that lived in the same house as Alex Jones and could see the madness on a first-hand basis. This is not something that we're just guessing, or this is the actual person that married him and was there. So it will be an excellent and amazing discussion, interesting, and you don't want to miss it, especially at this time when he's at the forefront of everything. He's Alex Jones everywhere. So looking forward to that.
Okay.
Yes, yeah. I'm very excited. And even though it's not on my show day, I'm still coming on to do it.
Yes. Casey will be joining us as well for that, because it's going to be this is a big thing for us, and I think it's going to be rather entertaining, because you know what they say, hell hath no fury like a woman scorned.
Oh yeah, he is a fucking nut job.
I think Alex Jones is about to get a pretty serious case of the act.
Yeah.
And so join us on Tuesday. Once again, thank you for joining us, Dr. Croon. This was a pleasure. It's always good to have people like you come on here and give us a break from the crazy that we deal with on a regular basis. So thank you again. We'll put all of his stuff in the channel description so that you can link up to it. And then join us on Tuesday, where we will unplug InfoWars for 2 hours with the former Mrs. Jones.
All right. Cool.
Now we're. I don't think they can hear us now. We're clear until we do the end card, and then we're